Excellent. Hi, everyone. Thank you for choosing to spend the next hour with me. My name's Adam. I work for a company called Particular Software. We're the makers of a product called NService Bus. Has anyone heard of NService Bus at all? That's about half of you. I am going to show you a few things to do with that in this talk, but that's not the point here. I'm going to talk about a certain class of problems which not many people actually talk about that often. It's to do with the runtime behavior of your code. You might say, well, I do think about the runtime behavior of my code when I write it, and that's true, but there are a certain class of problems which only really manifest themselves at runtime. They may be quite difficult to predict beforehand. And in particular, I'm going to talk about the arrow of time. So the arrow of time is a term coined by a guy called Sir Arthur Stanley Eddington, and he said that time only moves in one direction. You can't predict the future, and of course you can't. I'm not going to try and predict the future, but we can kind of fold things that need to happen in the future into our current code. Now, I'm going to sort of take a few ideas you may have seen and kind of invert them and turn them upside down and tear them apart. I expect that to raise questions, so I don't know if I will have time for a Q&A during this session, and actually it's lunch right after this, right? So I'll try and let you out a few minutes early to get ahead of the queue. But I will be at the Particular Software booth just outside in the hall throughout the whole of lunch and most of the rest of the conference, so please do not hesitate to come and grab me and ask me about this stuff. I love talking about it. So I'm going to take a fairly familiar example. I guess you've all probably seen Amazon at one point or something similar to it. So it doesn't need much explanation. It's an e-commerce site. But the thing is, if you are in this kind of area of business and you are running some kind of e-commerce site, first of all, you are up against Amazon, and you're up against a whole load of other people, and you need to try and differentiate. So I'm going to take a very simple case. The business might come to you and say, you know what, we're going to try and give customers discounts. So something like, just to keep it simple, if a customer orders more than £100 worth of goods within a week, we're going to give them a 10% discount, okay? Right, fairly simple. So you think, all right, great. I'm going to use domain-driven design, and we're going to use object orientation, I'm going to use event-driven architecture and all the rest of it. I'm going to make this nicely encapsulated, use all the techniques I've heard about, just like I've tried to use all the animation techniques in this slide. And you come up with some nice tested code and some nice object-oriented code, and it's all nice. We're not doing anything particularly fantastically complicated here. We're taking so when we submit this order, right, we're going to take all the orders where the customer ID equals this order's customer ID, okay, so all the orders for the current customer. We're going to look at all the orders which have a timestamp greater or equal than now minus 7 days, okay, so in the last week. We're going to total those up, and if the week total is greater or equal to £100, we're going to give a 10% discount, otherwise 0. Great, right? And then we do other stuff to actually process the order. Looks fine, right? So that goes into production, and it seems to work. What's the problem? Now, I did say, okay, you might say, well, you know, this is a big query on possibly like a massive database table or something, so you might kind of slow the database down and stuff like that. But you can optimize that, work with your DBAs, get indexes created and all the rest of it. There's another problem, though. Remember I said customer, so that can be an account for a company. User is not necessarily customer or account. There can be 2 users within that company. There can be 100 users within that company. 2 people may click the button at the same time. Let's say that they've been ordering things for £10 each and they've made 9 orders, right? They're going to see a sum of, that word wrapping is unfortunate, but the sum is 90, right? They're going to say the sum of the current orders is 90. What discount level are they going to give? It's less than 100. They're going to give a discount level of 0. So both of these orders get discounted at 0. The bill comes at the end of the month, and the person paying the bill has a look and says, hang on a minute. We've made 11 orders in this week at the beginning of the month. Why didn't that 11th order get discounted? And you're kind of scratching your head and you say, well, we did release that code. We did release that feature into the system. You should have got the discount. So you go to your logs and you're kind of trawling through and you're working out, and then you realize, oh, hang on a minute. this happened at the same time. You clicked at the same time. Can you just wait a few minutes before clicking that second order? The customer looks at you and says, what? How am I supposed to do that? I've got 100 people in this office and they're all ordering. I don't know when they're ordering. You say, well, I don't know. Hold up a sign to say that I'm ordering when you're ordering. The customer says, you know, that's ridiculous. I think I might just go to Amazon instead. Has anyone heard of the term death by Amazon, right? If you don't run your business efficiently and well enough, that's what tends to happen. And Amazon tends to eat you. And then you think, okay, well, I know how I can do this, right? The answer's obvious. Transactions, right? We're going to wrap this in a transaction. So we're going to put these things into transactions. We're going to make sure the read can't read something which hasn't been updated by the other transaction, et cetera, et cetera. The problem is that the default transactional level in, say, SQL Server is read committed. So they are still going to see the 90. So you think, okay, I need to make that serializable. Don't forget we're doing big queries across a big table here. And you roll that into production, and all of a sudden, your error logs start to fill up. And it's like, oh my God, what have we done? Like, quickly roll that back. Because you're getting deadlocks and all that kind of stuff. And what you need to realize, though, is that those error logs are telling you something. They're telling you that you've got a highly concurrent system here. You've got lots of users ordering at the same time. That's great, right? Good business, well done marketing. But you've got concurrency problems. You need to figure out a way to solve it. So you think, okay, another thing I've done in the past is I've used a batch job. So you might write some code like this to say, we're going to loop through the customers. For each customer, we're going to do a very similar thing to what we saw before. We're going to say, grab all the orders, where the customer ID equals this customer's ID, where the orders in the last week, sum them up. If the sum is greater or equal to £100, discount 10, otherwise discount 0, right? Great, and you update the customer table with that, saying this customer's discount is 0. That tends to work quite well. Although there is one glaring problem with it, but before I go into that, I will say that if you're lucky, you get to write this in C#. But I'll give you a tip. Don't ever let your DBA see it. Because when I made that mistake, they rewrote it for me, right? I've got this nice stuff with my nice C# classes encapsulated in the database. They replaced it with a SQL statement. And they gave me a stored proc and said, nope, you're running this instead. And this is actually quite hard to argue with, because this is almost certainly, with all the tuning they can do and all the query hints and all the indexes they can do, this is almost certainly going to run better than your C#. And they'll very often give you the first version of the stored proc and say, that's yours now, go and look after it. Now, what's happening here is that the business like this, because it works, it's very efficient, and then all of a sudden another one appears. And this is just random SQL I copied from the internet. I don't even know what it does. And then another one appears and another one appears. And what's happening here is, has anyone heard of the strangler pattern? I think that might be in the gang of 4. That's about half of you. Strangler pattern, very briefly, is where you take a really nasty piece of code and you kind of carve out bits of it one by one, replace it with nice code, until that bit in the middle is kind of strangled out of existence. This is almost like a kind of reverse strangler pattern. Because what happens is, all that nice DDD and TDD code that you wrote in here is kind of shrinking in importance. The interesting stuff, the new requirements, the differentiators that the business will come to you with are all out here, right? This is becoming the system. And I talk from personal experience because I've lain awake at night wondering how I'm going to debug that stored proc tomorrow. You know, it's very, very difficult to test these in the same way that you can test this kind of stuff in the middle here. And sooner or later, I realized that I had a big ball of mud, right? I just had this little thing in the middle with all these stored procs bolted on the outside doing all the interesting business work. And it was very hard to kind of think about. So what we need is, but the thing is, even if you manage to avoid that problem and you manage to keep it in C#, you've got one very obvious problem here. This runs overnight, for example. It might run a bit more often, but it runs some certain set period. It doesn't continuously run. If it runs overnight, what you're doing is you're no longer penalizing users for clicking on at the same time. You're penalizing them for clicking on the same day. So you've taken a race condition and effectively expanded it to an entire day. So you kind of say to the user, well, you know, do 10 orders, wait till tomorrow for the 11th. Okay, I'm off to Amazon. Doesn't really work too well. So you could do things like retroactively apply discounts. You could say, okay, well, what orders did you do in the meantime, and kind of retroactively give the money back. So you see your card getting charged and then credited again. It's just weird. It's just not as good as the way Amazon does it. So we need to think about something else. We need to think about this arrow of time again and what it actually means. So let's have a look at it. This is the arrow of time. As orders come in, obviously we process them and we store them in the database. Now, the business has said to you, when an order comes in, I want you to look at all the orders for the last week, add them up. If the total is greater than or equal to 100, give a discount of 10, otherwise 0. The thing is that is not a requirement. That is a workaround. The user has just given you a workaround within the constraints of their knowledge of the current system. A requirement is, when an order comes in, if the customer has spent more than £100 in that week, give them a discount of 10. That might seem like a subtle change in wording, but we've gotten rid of that. You must look back in time. You must sum up the orders, blah, 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 blah. They're not talking in terms of the system anymore. They're talking in terms of the pure business requirement. Now, by getting rid of that, look through the previous orders, we've freed ourselves up to do something else. Let's have another look. The arrow of time again. When the first order comes in, what's the current week total? 0. Exactly. The current week total is 0. So we process that order, we look at the week total, it's 0, we process that order at the discount level of 0, then we add the current order's total to the current week total, and we store it in the database. We then send ourselves a message 1 week into the future to say, in 1 week, take away this order's total from the week total. So you can see, for the duration of that week, that order's total is going to be in there, right? That week total is going to be correct for that 1 week. When the second order comes in, we do the same thing. We add the second order's total to the week total, and a week from then, we take away the second order's total from the week total, right? We send ourselves a message to do that. And then we take away the total, and then the same with third message, we do exactly the same thing again, and you can see what we've got now is this sliding window, right? At any point in time, we've got this sliding window of what is the total for that customer for the past week in that one number, right? The week total. When an order comes in, and so forth and so forth and so forth, when a given order comes in, what do? Do we look back at the history? Do we look back through the table and scan it and try and find out what orders we need to take into account? No, we do not. We retrieve a single row from the database, a week total. If that's greater than or equal to 100, we have a discount of 10, otherwise 0. So what we're doing is anyone here into DDD? Does anyone like DDD? That's quite a few of you. So in that case, this is right up your street, right? You know the whole thing about ubiquitous language? This has just entered your ubiquitous language, right? A week total. And you can see it in your code, right? You're writing code in terms of that ubiquitous language, right? You're getting deeper insights. So we're folding the history into our current state in a highly consistent way. You can almost think of this as kind of like an inverted, backwards, kind of inside-out batch job. It's highly consistent. The thing is, how are we going to actually program this, right? We need a good way to program time, that thing about doing the thing in the future. As far as I know, HTTP doesn't do this. Right? I do not know a way of sending an HTTP request now and having it arrive in a week's time. System.threading.timer, yes, that would work until your process crashes. Right? And then you've lost your system.threading.timer. So you see something a bit more persistent. So I'm going to introduce now this notion of a saga. I'm not going to go into too much detail about what a saga is. If you do want to know more about that, have a look at this URL. Take a photo with your phone or whatever. That goes into it in great detail. What I would quickly say is that saga in this context was coined in the 80s. It was a way of breaking up big transactions into smaller ones and having a long-running process with some state. It was initially kind of more about rolling things back. So it's almost like you do one part of a process, you do the next part, you do the next part. And if something fails, you kind of roll each part back consistently. The real world doesn't tend to work like that. Normally your business people will say, well, don't just roll back the whole thing and give the person their money back. Do something else. We'll find another way. We'll send an alternate product. We'll send them a voucher. We'll do something else. So it's more about when you find a problem, you find another path to get to do what you're trying to do, and ultimately, which is to get the customer's money. So putting it very simply, a saga is a thing that receives lots of messages. It receives the first message, stores some kind of state, receives a second message, and what it does with the second message depends on what happened in the first message, right? That's really a saga in a nutshell. And obviously that state that it stores in between is whatever it needs from the first message. So if you want to see that in more detail, do follow that. Now, how can we actually do that? How does that apply to this? Well, if you look at this, that's actually what we're doing, right? We're getting one message, we're storing the total, and then when we get the second message, it depends on what was in the first message, right? The first message may have been an order for £110. And in that case, when we handle the second message to submit an order, we're going to discount that order by 10, right? So it's a very, very obvious use case for a saga. And what we do a week later also then obviously depends on what happened in the first message, right? Because we are taking that week total that we stored and we are mutating it to take away that order in a week's time. So how do we code this, right? So let's have a look at some code because it's a bit abstract. I know that people like to see code. It helps them understand these concepts. So this is a saga, right? And a saga, as implemented in the service bus, is just a class, right? It's just nothing other than a C# class. I'm calling it discounting because that's kind of the purpose here. And the first thing we need to do is to think about that state. So what I've done here is defined a nested class called discounting data, which is going to hold our state. I know some people don't really like nested classes. I'm kind of I find them a bit icky myself. But for this case, I actually quite like it. I think it's a nice way of expressing that this is very, very private state to this saga. It encapsulates this, and it's only for the use of this saga. So I think for this use case, the nested class kind of works fairly well. But it doesn't have to be nested. You can just define it anywhere. What we do here is we inherit from this base class. This contains, I think I should say contains, or is it contain? It is indeed contain. This is just a base class which gives us some things like the ID of the saga, who sent the original message ID. It's not interesting to us right now, just to show you what that is. It's just an infrastructure thing. It's very useful for some things, but not so interesting for us right now. And other than that, it's just a C# class with some properties. We're defining a customer ID because we want to do discounting per customer. So obviously we need to know which customer we're doing the discounting for. And then we've got our magical week total, right, which is the thing we're really interested in. I'm using a double just to keep the demo simple. You probably wouldn't do that in production. You'd probably use a money type or something like that. Then once we've got that class for the state, we can then say that this is a saga by inheriting from this saga base class. And we say that this type parameter here is the state that it holds. So it's saga of type discounting data. Then we need to handle, obviously, our submit order message. And we want to be started by a submit order message. And incidentally, this doesn't just mean started by. It means I'm started by a submit order message, and I handle all the ones that come after that as well. And that gives us a method to implement called handle. If you've seen an end service bus handler before, this is exactly the same. All we're doing here is handling that submit order message. And submit order message just looks like that. It's got an ID for what it's worth. It's got a customer ID. It's got a total of the order. It'll have other stuff on it as well, right? I'm just leaving it out for brevity. Then we get this context object. That's just an infrastructure thing that you can use to send messages out and do other things. I'll show you that in a second. Now, to work out our discount, as I said in one of the previous slides, it's very, very easy, right? We just look at this one thing, this week total, right? So when When this method gets called, the state has already been loaded, and it's on this data property of the base class, and then we've got our week total, right? So working at discount level, very, very, very easy indeed. Once we've got that discount level, we then send out another message to process the order, and we've got the order ID on there, we've got the discount level, we'll have other stuff as well, right? I'm just leaving it out for brevity. Then we add this week's, this order's total to our week total, right? So we record it for next time we get an order. And then comes the magic part. We request a timeout. We pass through, this is a method on the base Saga class, we pass through this context object I mentioned before, because that's just required. We say 7 days from now, right, in a week's time, and we just pass along the original message. We could pass along anything here, but I may as well just pass along the same message again, because it's got that total on there that we need, because that's what we need to take away in a week's time. Then we need to say that we handle timeouts of type submit order, right? As well as handling the original submit order, we handle timeouts of that type as well. That gives us a timeout method to implement. For one reason or another, that's called state. I don't know if that's an accident of history, but that's the name of the thing we get in. And as you've seen, we're sending that same message through, so it is a submit order message. We get the context object if we need it. We don't need it this time. And then we do something dead simple, exactly what I said before. We take away that order's total from the week total. All right, and we're done. And then we've got our async tax here. I don't know if anyone loves async or not. It's a little bit kind of verbose sometimes. And yeah, then we're done. I hope that makes sense, more or less. It's fairly simple code, as you can see, right? It's not rocket science, fairly easy to look at and understand. What's interesting now, I think, is to show you what happens actually in the back end. So what happens at the kind of infrastructure level. So let's switch back to our slides. Where are we? Here. Yeah, I'm showing you the code. Right, so let's see what actually happens when we do this. What we've got here is a bus abstraction, which you can kind of think about as the thing that kind of like looks at the queue. And we've got a persister, and a persister is really kind of an abstraction over a database, right? And these are components that NService Bus provides. When a message is delivered, the bus realizes that a Saga handles this message, and it loads that Saga from the database, right? It loads that state from the database and dispatches that message into the Saga by calling the handle method. Then we do what we just saw in the previous slide, in the code. The Saga does that work, and it requests this timeout. The bus now does one of two things. It either, and this is the preferred method, it either tells the queuing system how long to delay that message for. So it just says to the queuing system, deliver me this message in 1 week. The only queuing system that we support, or that we've seen, which supports this fully, is Azure Service Bus. So Azure Service Bus, we can just say, give me back this message in a week. Azure Service Bus, incidentally, is just a queuing system, right, despite its name. It's very low level, so it really is just a queuing system rather than what we refer to as a bus. Amazon SQS kind of does it. I'll come on to that in a second. RabbitMQ, you can kind of make it do it, a bit more than that in a second as well. If the queuing system doesn't support delays at all, like Azure Storage Queues doesn't, MSMQ doesn't, although we don't really encourage MSMQ anymore because it's actually gone out of support now. We use SQL Server as a queuing system. That's got no natural mechanism for doing this either. So in that case, we put the timeout into the database, right? We actually record the fact that this timeout is due in the database. And we persist the Saga data at the same time, regardless of which delay method we use. And that all goes to the database. And then we poll, if the timeout's in the database, we poll the database to find out when the timeout's due. That's not nice, right? We don't like polling the database. So we always prefer using the native queuing system instead and letting that do the work for us. So I did say that Amazon SQS kind of does it. Amazon SQS lets you delay a message for up to 15 minutes, right? So 900 seconds. If you want to delay a message for 600 seconds, you're fine, right? You just put it into Amazon SQS, say, give me this in 600 seconds, and it will do so. If you want a 2,800 second delay, a little bit more difficult. You can put it in the queue for 900 seconds, at a maximum. What we figured out is, well, we can just put a header on that message to say when we get that back, we still need to put it in the queue for another 1,900 seconds, right? So we get it back, put it in the queue for 900, write a header for 1,000, 900, write a header for 100, put it through 100. It's done it for us, right? It's put the message through the queue. Unfortunately, we have to hop off the queue and back on again 1, 2, 3 times extra, but it's doing the work for us, so we prefer that. RabbitMQ is a bit more interesting. RabbitMQ has this notion of time to live. And what that means is for a given queue, in RabbitMQ, you can say messages in this queue live for 60 seconds. After 60 seconds, transfer them to this other queue. And what we can do is not subscribe to the original queue, subscribe to the other queue, and by putting it into the first queue, we have a delay of 60 seconds. See how that works? And that works pretty well. So you can put it in a queue with a 600-second delay, you can put it in a queue with a 900-second delay, you can put it in another queue which has a 1,500, and so forth and so forth. But you might be spotting the problem here. You have to create a separate queue for each delay level. And sometimes 1 might be enough, sometimes 4 might be enough, sometimes you might have a lot more. And the thing is that the API is very, very flexible. I can basically write whatever I like into here. Right? I can have thousands of different delay levels if I want to. I can be really evil, right, and write random.next and multiply it by something, whatever. And the last thing we want is people saying to us, why is Service Bus creating 10,000 queues in my broker? And so, well, because you've got too many different delay levels, use less. Okay, I think I might look for another solution. So we do need a better solution to this, right? Because the API says you can delay for any time of length of time you want. So let's take a simple example, 42 seconds. We love the number 42. But we know that the number 42 is only written in that way with the digits 4 and 2 in a certain counting system, right? In a certain number system called decimal, right? Or base 10, right? That's how we write 42 seconds. But we are computer programmers, so we know there are other ways of writing numbers. We know about this binary system. We can write this number as 101,010 seconds in binary. So what we can perhaps do is create a queue for 32 seconds, a queue for 16, a queue for 8, a queue for 4, 2, and 1. And we can take our number 42 in decimal, we can write that in binary as 101,010 alongside those queues, and then if we put it through the 32-second queue, skip the 16, put it through the 8, skip the 4, put it through the 2, skip the 1, we've just simulated a 42-second delay, right? 32 plus 8 plus 2. So we think we like this solution. We've not seen anyone else do this, right? We kind of came up with this and thought, this might actually work. It's a nice kind of fusion of basic computer science, binary and actual real-world applications. It works pretty well. We actually use headers, again, to do this. So you can put a header with the binary number into RabbitMQ, and you can tell RabbitMQ, I think we do it via regex, we actually say to RabbitMQ, look at the binary number, and if that one's 1, put it in that queue. If that one's 1, put it in that queue, et cetera, et cetera. So it works pretty well. We can't delay messages for that long with these queues. I mean, if we've got these, 6 queues, the maximum delay is, 63 seconds, not that useful. So we actually have 28 queues. That gives us a maximum possible delay of 2 to 28 seconds, or that many seconds, or about 8.5 years, which I think is enough for anyone. Why did we go with 28? Well, we first thought 25, because that will give us just over a year, and no one really thinks much in terms of more than a year in business. 25 is odd, so that's 26 is even, so let's go for that. And we thought, well, we think that's enough, let's just go 1 order of magnitude higher. It's only 1 extra queue, let's go to 27. And we thought, no, that's odd, let's make it 28 because that's even. So we ended up on 28. We were really tempted to go for 32, right? We love 32, but that would give us a maximum possible delay of 136 years. It'd be nice if someone was using a service bus in 136 years, but it's a bit of a stretch of the imagination. But if anyone wants more than 8.5 years, we'll add a 29th and probably add a 30th to make it even, whatever. But it's more than enough for now. But you might be thinking, well, that's all fine, right? We've figured out how we can do this in this nice, consistent way, but don't we just have the same problem all over again, right? Isn't someone just going to press the button at the same time, right? And aren't they both going to see the sum of 90 with a week total of 90? Well, yes. I mean, I haven't stopped people from clicking the button at the same time by introducing sagas in the background, right? It's going to happen. But remember that we are now looking at a single row in the database, right? A single row with customer ID, week total. Databases are exceedingly good at guaranteeing transactionality around a single row. But even with that, what you have to make sure of is that if we look at this code, what we're doing here is we are retrieving that single row here, and we are writing back that single row there, right? All you're doing is adding things to property here, but in the background, when you persist, that gets written into the database as that single row. We do not want that to happen and succeed without that bit there succeeding. Right? We do not want to send out the message to discount if we fail to write the week total back because of concurrency, because that means another order's done that at the same time, and we're using them on discount level, potentially. Right? So all these three things have to either fail or they all have to succeed. Right? We want transactionality around the state of the saga and sending messages out of the saga to do work, right? Because those messages are only valid if that state is valid. So we need to wrap that in some kind of transaction. Now, how we do this, what actually happens at runtime is we have these two sagas, we have these two users clicking at the same time. So what happens is those messages may get handled at the same time, right? We do default to multi-threading, right? So two messages can be handled at the same time by two instances in memory of the same saga. They both have their handle methods called. All that stuff happens that we've seen in the code. And then they try and write the saga data down into the database, right? And the database, as we said, is very good at guaranteeing transactionality around a single row. It will allow one of them to go in, the messages will be sent from that one, and that one will succeed. Here, things will fail, and the messages will not be sent. Then what happens is that message will go back to the queue. Essentially, that's a failed message handling scenario. It will go back to the queue. It will get retried, which NService Bus does for you, but otherwise you have to write that yourself. It will get dispatched into another instance of the saga in memory, and this time it will read the state that was written by the other message, and it will try and write back the new week total, and the messages will be sent, and it will succeed. How do we actually do that? How do we actually guarantee that transactionality? Well, for some queuing systems and some databases, you can just wrap the whole thing in a distributed transaction, right? So if you're using something like MSMQ and SQL Server, you can wrap those things in a distributed transaction, and Microsoft's infrastructure takes care of that for you. Like I said, we don't really encourage MSMQ anymore because Microsoft don't really support it anymore. So really, that's a kind of disappearing scenario. We need something else. This is how we do it in NService Bus using the outbox pattern. This is another entire talk in itself. If you want to know about that, do follow this URL, have a look at the outbox. It describes it in excruciating detail. It involves writing something to the database and then trying to figure out if messages have been dispatched. Every time I read, I actually wrote a lot of this article, but I still have to go back and kind of remind myself, how does it work again? But it's been in production for ages and ages and ages now in a lot of systems, and it does work. So we use this outbox to guarantee that transactionality between queuing systems and databases which don't naturally have it. Right? It's very, very important that that's consistent. And the great thing is that these sagas live in that code. They live in your nice DDD, TDD, whatever your methodology you're using. It sits alongside the rest of your code. It's not some batch job that's plugged in on the other side. It is actually something that lives in your code and is highly testable. We actually provide a testable message handler context in another package. So when you're unit testing, you can pass that in. You can pass in a whole load of messages, and then you can look at that context and see what messages were sent out. Right? So they're very, very highly testable. So we're on the way to killing the batch job. If you want to see more about that, do go to this blog post, Death of the Batch Job. We are on a particular software kind of on a little bit of a mission to try and kill the batch job because we've seen it used so inappropriately in so many circumstances where other methods are much more useful. But you may be thinking that the scenario I've just described, okay, yes, we can remove the batch job in favor of something else in that scenario. But you might be thinking, well, I have this other scenario in my system where a batch job is just totally the right answer. This totally makes sense to be a batch job. And one of the areas that I've seen this in my career is in reports, right? Has anyone worked here with a system which produces any kind of report? Anything? Yeah, that's actually probably about 80% of you. So I've worked in systems which have produced overnight reports, and they've sometimes, I mean, this is a good indicator, right? If you're doing really well, business is booming, you're getting loads of orders, these reports are getting more and more expensive to produce, that's good in a way, but I've been in situations where it runs overnight and starts to finish around lunchtime the next day. And it's kind of creep. I see a few nodding heads here. I see other people have seen this. And it starts to creep, right? And I remember we kind of like had a side bet on how long it's going to be before it takes until the end of the next day for the batch job to run. And you know, it was pretty scary because the business were finding it's very difficult to actually do their jobs, getting the reports that late. And then of course you open an office in Singapore and you open an office in New York and San Francisco and you don't have any night anymore. So it's kind of a bit of a problem. But the thing is, reports are interesting because they tend to be required at a certain time during the day. So let's take a banking scenario, for example. The user might say, well, okay, here's my requirement. I need a report at 9:30 every day of all the transactions in the last week of a certain size. I want to see the customers against those transactions, group them by customer for me, that would be useful. And I want to see in which location they are. I want to see in which country they are. And you say, okay, that's interesting. What are you going to do with that information, by the way? You say, well, I'm going to look through them, and if I see 3 large transactions in a high-risk country for a given customer, I'm going to tell my manager and start a fraud investigation, because we think that's like a little bit dodgy. That is not a requirement. That is a workaround. They know that we store the transactions in the database, right, the account transactions. And they know that if they look at them, they can figure out, using the data in there, if there's possible fraud. But the actual requirement is, if there are 3 large transactions in a high-risk country for a given customer in the last week, I want to know about it. That's the requirement, right? Forget about how the system currently works and your knowledge of it. Give me the requirement. That allows us to do other things. We can go in and say, well, I'm going to do some kind of automated pattern matching, right? I'm going to create a saga, and when that saga receives a transaction occurred event or something, or some kind of message, I'm going to look at that and I'm going to say, first of all, is this a large transaction, right? Remember that thing I said about ubiquitous language? Starting to get enriched again. You've just learned there's such a thing as a large transaction, right? Like more than £10,000 or something. I'm going to look at high-risk countries, right? Again, you've learned there's this thing called high-risk country. You can actually now see high-risk country as a variable name in your code, right? You're getting deeper insight into the business problem here. I want to know if there's been 3 of them in the last week. So, similar to what we did before, we can receive a transaction occurred message. We can say, is it high risk and is it large and in a high risk country? Yes. Add it to my current possible fraudulent transactions collection, right, on my saga state. Send myself a message in a week's time to remove that transaction from my current possible fraudulent transactions. And in exactly the same way as a week total, we've created this sliding window of, for the current week, what is the collection of current possible fraudulent transactions, right? Anytime I receive one of those messages, if I've already got 2 of them, and this one is also a large transaction in a high-risk country, I've got 3, right? Alarm bell, email the user. So you tell the user, and they get a notification, they go to their manager, And imagine this is like, and this is kind of mind-blowing, right? Because it's real-time business information, right? You say to the manager, yeah, I've got a high-risk situation here. I think we need to investigate some fraud here. And the manager says to you, but hang on a minute, hang on. It's 4:30 in the afternoon. You get that report at 9:30. Why the hell have it taken you 7 hours to tell me about this? This is ridiculous. Like, step up your game here. And you say, no. This transaction occurred in the last 2 minutes. And say, what? But hang on a minute. How do we know? And he said, oh yeah, the system told me. It's like, yeah, you know that Saga thing the developers were talking about a few weeks ago? Yeah, they implemented that. They released a new version of the system. And now it just tells us. And this is mind-blowing. The manager's like, oh my God, so we've got real-time business information here, right? And I said, well, how do I want more of these Sagas. How do I get them, right? Where do I sign up? And what's happening here is this is actually translating into this actually does translate into real business value, right? This is money we're talking about here. We are now reacting real time, right? We prevented a possible 24 hours of possible further fraudulent transactions, right? You're turning into a profit center, right? Your system is turning into a profit center by adding this real-time information. So I'm coming towards the end now, and I've absolutely raced through that, but I'm sure you're going to be happy to get to lunch a little bit early. If you want to know more about long-running processes, sagas, stateful message handling, that kind of thing, I've actually prepared a set of videos for you here. So if you follow this URL, ndc-london-batch, go.particular.net, do take a photo of that. That's a set of videos by our company CEO, a guy called Udi Dehan, who you may have heard of. It's actually a 5-day course that he runs, and I've just prepared an extract from that. So that's completely free. Go and register, go and have a look there and grab your free videos. I hope you've enjoyed this. What I've tried to do here is show you a program model which embraces time, a program model which allows you to enrich it encourages you to enrich your ubiquitous language if you're into DDD. I said that, so sagas are actually, if you're into DDD, you've heard of aggregate roots. So a saga is actually a very good aggregate root, right? In fact, it's actually just a very good object. If you've ever read anything by Alan Kay, who talked about object-oriented programming in the early days, he never talked about polymorphism and inheritance and that kind of stuff. What he actually talked about was an object being something that receives a message, encapsulates state and business logic, and send a message out. Right? That's the essence of what he described as an object. So sagas are actually very, very, very good objects. Anyone here into TDD? Anyone like TDD? That's probably slightly less than half of you. TDD tends to be one of those kind of love-hate things. I bet the people who didn't put their hands up hate it. I've kind of like swung between the two kind of opinions a little bit myself during my career. I think one of the problems with TDD is that we don't often have very good units to test, but a saga is actually a very, very, very good unit to test. Right? I can actually show you, I've got some time left, so I can actually show you that test framework that I told you about. I've got a test here. Right, so what I'm doing here is I've written a test called 10% discount. I'm creating, let's just get rid of this. Oops, just get rid of that. So I'm basically simulating a new saga. So I'm saying I'm going to create a new saga class, because remember, it's just a class, right? I can just create one. I do need to pass the current state into it, which is just a new discounting data, right, with nothing in it. So everything's going to be initialized to 0. I then take 4 submit order messages. And of course, I'm omitting properties and things like that, which would normally exist. One's for 60, one's for 60, another one for 10, another for 20. Then I create this testable message handler context. And this is the thing we supply as a special testing harness for sagas. I can call my handle method with a first order, passing that context in, and then I can look at sent messages. Right? So I can see within that handle method that the context was passed into, what messages were sent from within that handle method. And obviously, I want a discount level of 0 for that first message, for that first order. because the current discount, the current week total is 0. Now, the week total should be 60, right? Because the total of that first order was 60. When I receive the second message, which is again is 60, I should still have a discount of 0, right? So the discount should have been 0 for that second order. The week total is now 120. When I receive the third order, I want to have a discount of 10 because the current week total is greater than 100, right? It's 120. The week total is now 130, but we're going to pretend that a week has passed since order 1. So we're going to handle a timeout of order 1. And now we should see the week total drop by 60 down to 70. We handle the fourth order, and we should have a discount of 0, right? And we can look at the data and things like that to make sure that other things are happening. But this is just showing you how to test that one aspect of the discounting level being correct. And this is a very simple example. You can have sagas which handle many different types of messages, and the logic inside this handle methods is much more complex, but you can kind of test, you can actually write good unit tests against all of this. And I do recommend this, right? I do recommend testing sagas, especially with the aspect of time, because you don't want to be kind of writing a test which lasts a week, right? You want a nice way to simulate that, and you don't really want to have to like advance the system clock and stuff like that. It's much nicer if you can just pretend in your code, oh, a week's passed, I will just say timeout's there. So, switch back to the slides. Yes, so as we've seen, a lot of these problems do root from being given workarounds instead of requirements. So do try and push past those workarounds and look to the actual requirements. If you hear someone telling you how a requirement in terms of how the system works, that's an alarm bell, right? You want to be able to talk to the domain experts who can kind of like release themselves from that. Business analysts are sometimes a bit of a problem with that because they're kind of like, some people call them proxy domain experts or things like that. They kind of tend to have one leg in the system and one leg in the business, and they can't help themselves but think about how the business works when they're trying to interpret a business requirement. So just watch out for that, right? Try and get past those workarounds. Talk to the business. Try and get requirements in pure business terms, forgetting about how the system works, right? Because that's your job. You're the best people. You're the people that are best placed to figure out how the system can make that business requirement happen. It kind of does stem from some organizational problems. You know, a lot of problems we do have as developers are organizational, and they're not actually that often that technical. So it's just something to watch out for. But that's another talk in itself. We've gone through that very quickly. So does anyone have any questions here? Because we've got 10 minutes left, so we're going to maybe a couple of minutes if anyone's got any questions. Yeah.
Go from weekly discount to monthly discount, because then you have to actually build a batch which will rerun and recompute all the sagas. And in that, there is some trade-offs comparing to initial approach where you do compute things in place. Of course, you still have this concurrency problem, but as you said yourself, you have databases which are extremely good in solving this concurrency problem. So, so what do you think about like if that becomes a trade-off that rules really sort of organization wants to have rules changeable in that sense?
Right. Okay. So I'll try and sort of paraphrase your question into saying that we've looked at an example where we have this discounting thing at a week total, which is very easy to think about, but the thing that you're seeing as possibly problematic is this fixed week window. And the business might come along and say, and it's a very good question actually, the business might come along and say, yeah, that thing we're doing for a week, we want to extend that to 2 weeks. Now, in that case, you do have to take some action, some initial action to change to 2 weeks. The thing is that your timeouts are still going to be in there, right? They're still going to be being delivered in a week's time. But what you can do is, and this comes down to versioning, you can release a new version of your saga which just ignores the week timeouts, right? It just ignores those original messages because ultimately they're just messages that are going to sit there and we don't need them anymore, right? But you will have to do some kind of initial migration to say, well, we're now going to set up, we're going to look at the orders, but the thing is, it's a release time thing, it's not a runtime thing. So as part of the deployment of that new version, yes, it will involve a migration, right? So I'm not saying this is a way of getting rid of data migrations, it isn't, and that's going to be required in some cases. If it turns out that things are going to be a lot more flexible and kind of levels of discounts are changing for a customer depending on other factors as they go through their lifetime, you're going to have to do something more complicated. This isn't a golden hammer, right? It's not a silver bullet. So for those complicated situations, you may have to look to something else. But it's a good point. I think it depends on the level of variability. And sometimes, and actually, this is a good thing to talk about. If anyone here is involved in some kind of startup or anything like that, you don't really know what your business rules are yet, right? So doing things like this can be quite expensive, right? Because you have to invest in modeling and looking at things correctly. If you're in a kind of startup situation and you're trying to find out what the best way to do things is and what the best way to retain customers is, just write any old code. Because when you discover what your business is, you're probably going to have to rewrite it anyway, right? So don't invest too much of that and then in the early discovery parts of your business. This is very good for much more stable business rules, which have evolved through a stable, mature business that knows how things are going to work. But even still, you can have varying degrees of level of change. I hope that kind of answers the question. But it's the sort of thing we could talk about for hours, potentially. Anyone else? Yes?
Just thinking a bit more on what Paul was saying. A common rule might be a finance department wants monthly invoices to send to their big customers with all the transactions for that last month, which you would, standard approach would be to have a database query every month to go through the reports.
Okay.
Do you think that sort of like monthly finance reporting is something you also do as standard?
So monthly finance reporting, possibly like monthly invoice sending and things like that. Well, the interesting thing is about that is the monthly invoice sending in particular is very interesting because I wonder why the business is sending monthly invoices at a certain set period. Why isn't it sending an invoice at the time the order's made, dynamically as the orders come in? It sounds like something's been designed within the constraints of the current system. So it's almost like a batch job is almost self-serving in that scenario. I mean, obviously there's more context I'm probably missing. But, so other accounting parties might expect something at a certain time of the month. That's interesting. You could potentially, when an order comes in, send a message to send this invoice on a specific date. Obviously, you're going to get like a kind of like crunch of messages coming at the same time on that date to say send, a whole load of different invoices. So that might be problematic. Obviously, if your system is at such a stage where you've got so many of these customers, which is good, right? You've got loads of business, that you're finding it incredibly difficult to make your system send out all those invoices on that one day. This is a trap that's very easy to fall into. Don't necessarily try and solve that technically. Speak to the business. Say, our business has grown 10,000% in the last couple of years. We've got so many invoices to send out in a month. Can you not talk to the customers and say, can you be a bit flexible about this? Put half of them in the middle of the month. And I'll say, yeah, sure, we can work that out. Don't assume that that's a fixed thing. Talk to the business, right? Because so much can be solved by talking to the business and working out something different. So it's a very good general thing to always bear in mind. But if you want to talk about that more, please come and grab me after. So how are we doing for time? We're a few minutes before lunch, so I'll let you go now so you can get to the head of that queue. I hope you've enjoyed that. Do come and grab me if you see me, ask me about the stuff. Thank you very much.